Welcome everyone. Thank you for joining us for today's webinar. My name is Ankit Kumar Patel and I'm the head of Department of Aeronautical Engineering at PITDS in Parul University. Today we are presenting a webinar titled as an Introduction to Jet Propulsion presented by Dr. Jigar Sura. Just a little housekeeping before we get started. If you have any question during the presentation, please type them to my number. My number is 9978225359. I repeat again, 9978225359. I will bring them up during the presentation and we will also have time for the question at the end of the session. Now, without further ado, we will turn to time over to Dr. Jigar Sura. Our presenter today is an assistant professor at MIT University with a great knowledge and expertise on subject. Thank you, sir. Please start.
Thank you, Ankit sir. I am thankful to management of Parul University also for giving me this opportunity. And before beginning, let me switch off my video so that things are in order. Okay, fine. So welcome all of you, faculty members and students. So I will talk about introduction to jet propulsion. And I'm from, as sir said, I'm from Amity University, Maharashtra, and I'm working there for last 3 years as a department coordinator and assistant professor level. So, what is propulsion? It comes from the word called propel. That means to drive or to move forward or onward. That is going in the direction that you desire. That is propellant. Propel. So propulsion means an act of propelling or state of being propelled, or we are giving propelling force or impulse. So you can move in any direction just like that, just like wind. When the kite is cut from the thread, it goes any direction. That is not a propulsion. We should have the desired direction of the traveling. That's why we call it propulsion. From there, the word has come called propeller. In fact. So jet propulsion, there can be many means of propulsion like automobile engine, they have IC engines, ship also have some particular type of engines, aircraft also have particular type of engines, and anything that can give the energy to go in a direction can be called as propulsion system. So jet propulsion is uses the principle of momentum change of the fluid. So what it does, it takes in some fluid, changes the momentum, and Newton said that rate of change of momentum is force. You change the momentum in a given amount of time, how much force you will get. So two types of jet propulsion systems exist. One is called air breathing, another one is called non-air breathing. Non-air breathing means we don't need air coming inside the system. Air breathing means we need air as a part of our propulsion system. So in air breathing system, all the engines that you see in day-to-day life, they are part of that. Like IC engine, reciprocating engine, turbojet, usually good for fighter planes, turbofan, the passenger jet planes use those things, turboprop, mostly large size cargo aircraft, they use turboprop engines. Turboshaft means it is useful in helicopter engines usually, and ramjet is the very high speed jet engine which operates at really high speed. And the things that we are talking about, London to Tokyo in 2.5 hours or London to New York in 2.5 hours, that kind of flights are possible based on ramjet engine and other variants of the ramjet engine. So this engine need uh, air as a property or air as a substance to operate themselves. But when we talk about non-air breathing, we have rockets or nuclear propulsion system or electric propulsion system. The rocket motors, they carry their own oxidizer on board, so they don't need extra supply of air. Some types of missiles, they also carry fuel and oxidizer on board, so they don't need air coming from the outside inside the system. Nuclear propulsion, if you have seen Chernobyl, we don't need any air to operate that. It works based on uranium and that fusion and fission type of reactors and all these things. They don't need air as a important part of the system. Similarly, electrical propulsion system, they generate some ions and ions are pushed forward and then you get the thrust. It's like that. So non-air breathing, they don't need air at all. They can survive like that. And air breathing, they do need air. So we cannot go outer edge of the atmosphere with air breathing engine. We have to stay within the atmosphere with 21 percentage of air available to us at any time. Now, based on the type of the engine, there can be a flight limits or the envelope, as it called, you can operate within. So if you see on the screen, helicopter has the minimum Mach number as well as sort of low amount of altitude. And we know that helicopter don't fly at very high speed. They are not designed to fly at supersonic speed at all. Then if you want to increase in Mach number, you can use piston engine, that is reciprocating type of engine, and you can gain some altitude, you can gain some Mach number in terms of flight. And after that, if you want to go further, you need to have turbo engine, turbine engines, they call it. The minimum speed is available with turboprop engine. That is just higher, slightly higher than the piston engine they can operate, but they can go to very high altitude as compared to piston engine. Now, if you want to increase even after that, then turboprop engine will not work. You have to go with turbojet or turbofan engine. So turbojet or turbofan engine, they can give you high Mach number, but you cannot operate that engine at very low altitude continuously. So you will have maximum altitude or range of the altitude available is quite higher than the turboprop engine. So these engines, they are supposed to fly at very high altitude like passenger jets. They don't fly at some 10,000 kilometer or 2000 meter altitude. They always fly at 8 kilometer and above altitude so that your efficiency, your output from the engine coming can be maintained properly. Then once you have exhausted all the options for air breathing engine, you can go for ramjet, which is a extremis of air breathing engine, we can say. We don't have any component inside that. We have only a box, hollow box, and air is coming, it is compressed, expanded, and you get the thrust. So you cannot start ramjet engine on ground, unfortunately. And once you are at the limit of the ramjet engine, you have rocket engine. That is very high velocity, very high altitude. Orbital velocity means you are flying at 100 kilometer and above altitude, like international space stations and space shuttle and those kind of thing. That time you cannot use only air breathing engine, you need to use rocket engines. So if you want to fly at high Mach number, you need to fly at high altitude because temperature is there is very low and you can improve your Mach number. Then based on the amount of air and based on the flight Mach number, there are certain limits. As we have seen in the previous case, piston engine and piston prop engines, they fly at minimum Mach number, minimum altitude. Turboprop can fly at little bit higher Mach number, but less than 1 and higher altitude, up to 50 to 60,000 feet. But at very high altitude, it can affect the performance drastically. Then turbofan has a good amount of Mach number range. It can go very supersonic range also, and it can go to very high altitude also. Turbojet, even faster than turbofan, we can reach Mach number 3 and 4 ideally on design basis, and we can reach almost the same altitude as turbofan engine. So altitude wise, turbofan turbojet don't have much of a difference, but Mach number wise, both of them have the difference because their core principle of operation is same. Ramjet engine, as you can see, it does not begin at Mach 0. It will begin only at supersonic, close to 1.5 or 2 sometimes, to have efficient operation. And it can go to very high Mach number like 8 and 10, depending on modifications of design. And it has got ideally no limit as long as you have oxygen available. Okay, so based on the speed, if you want to improve, and you can see in your life, real day-to-day life also, A piston engine travels at the minimum speed, turboprop slightly faster than that, then turbofan, then turbojet, which are used in fighter jet or close to turbofan engine. Actually, they are not exactly turbofan, turbojet. And ramjet, they are in experimental stage. But certain type of missiles, they do have ramjet engines. But passenger on board and engine, ramjet engine integrated is not happened yet commercially. Remember. So 1903 was the year when we developed first airplane. We flew first airplane. In fact, you can say beginning of 1904. And after that, people started thinking about jet engine. Earlier, the Wright brothers plane was IC engine, reciprocating engine type. Reciprocating engine was used. So 1908, Loring, there was a guy who designed based on piston engine, one jet engine. Same person, after 5 years, again asked for patent on RAM-based supersonic flight jet engine, that is ramjet engine. And 1921, Gulame designed some engine based on turbo machinery. So soon after the development of the first plane, people started working on improvement of engine. If you talk about reciprocating engine, people are developing. It has reached to a saturation stage where we don't see much of a development in terms of design. Maybe emission is reduced, efficiency is improved, but the fundamental design remains same. Similarly, even aircraft engine, soon after the first aircraft flew, people started designing the engine which were more capable, having more power. But these were not known to anyone at that time. They did not have Google or internet in that era. So first patent for a turbojet engine was applied in 1930 by Frank Whittle. He was from UK. He was actually in UK Defence Forces. He died in 1996. So he is the first person who filed a patent for turbojet engine. He did not know anything about the previous patents at that time, and it was people had lost interest in his patent earlier era, but later on it was developed when they found that okay, it is suitable and we can go ahead with that. So it is actually Sir Frank Whittle, and the person who is responsible for the first engine from UK. The other person outside UK was Hans von Ohen, the one who has written so many books on gas turbine engines. He also died in 1998. So both are born in the same era, both died in the same time, close to, and both are the first person to develop the jet engine. The only thing was their idea was different. And during that time, during 1930s and during that time, it was not known to other countries that whether somebody else has filed a patent or not. So both of them never knew whether other person is working on the same time or not, on same type of system or not. So we can say that both of them are responsible to design the first gas turbine jet engine. And he was German, by the way. After the development of first engine or successfully flying the first engine, people started developing that. What were the goals? What is required to like achieve? What we want to achieve in terms of engine? So first is overall efficiency should be higher. That means thermal efficiency, propulsive efficiency, or any other efficiency coming from the engine should be as high as possible. Larger power output is needed. If you can get low power output, it's useless. Like Airbus 380 cannot fly with small engines. You need large engine on Airbus 380. Even the largest engine that has been used for Airbus 380, they need four of them. Then, for aircraft, weight is important. So, for the given power output, engine weight, engine volume, and engine frontal area should be as minimum as possible. Okay? That means energy should be contained or concentrated. So weight, if you come with the weight which is equivalent to plain weight with for the engine, then people will not use it. The volume, volume comes with some surface area, and if you have large frontal area, it will create the drag. So instead of giving you the good power output, it will only generate the drag. Then right now planes are flying about 12 to 20 hours in a single flight. So service life should be maintained. It should have good endurance and reliability. It should not happen that every now and then plane is on the ground just because of some maintenance requirement in engine. Okay, and we cannot have low quality components used just to save some money. It's not part of aerospace engineering. Reduction in environmental gases. Gas turbine engine generates so much of noise and exhaust gas. Even we need PUC. Aircraft engines also need PUC, and their requirement is more strict than ours. Okay, we can give some money, pay some fine, and get away without PUC. They cannot. And a reduction in noise is required because nowadays so many airports are coming, and those who already are there, like Mumbai airport, they are within the city limits. So if the engines are generating so much of noise, people will not like it. At least in India, we don't do go that way, but in foreign countries, they can file a case against the airport authority. It's like that. Even in European Union, there are certain countries which do not allow you to land during the night time. That's why we have flight taking off and landing at middle of the night in India to reach there during the daytime. So compressor is important part, the one that you see when you are standing in front of the engine while you board the plane. So that is the most important part of any jet propulsion system because it is responsible to give you the high pressure air ultimately. In the beginning, it was hardly 3 to 5 compressor pressure ratio. That means you give 1 atmosphere air, it will give you 3 to 5 atmosphere air, which you easily get nowadays using a centrifugal compressor from market. After that, when they started development on material, then they learn about aerodynamics and structural integration and all these things. It was improved. Like after 1940, it was reached 5 to 6 slightly improvement. Then after next 10 years, it reached about 10 to 1. Once we were through or we developed a proper aerodynamic methods and material development like composites, high temperature alloys and lightweight alloys, it increased a lot of amount 20 to 25, and even current era we go up to 30 to 40 pressure ratio. So you provide 1 atmospheric pressure, you get 40 atmospheric pressure as an outlet. So within 70 years, we started at 3, we ended at 40. That is more than 12 to 13 times higher the initial one. So design of the compressor is more crucial because it goes against the nature. You are compressing something. Compression is not a nature's law. You have to go from low pressure to high pressure. That is why the design of compressor is crucial. Earlier, before 1960s, here we started 1940 up to 6, 1950 up to 10. Then people did not talk about bypass ratio, the one that we see in our normal passenger jets nowadays. But in 1960, beginning of the 1960s, American Air Force asked for a typical type of engine for its cargo plane, and in 1964, General Electric developed this engine TF39. If I'm correct, it is used in C5 airplane even today. So that was the first time where we use high bypass ratio turbofan engines. So they are very efficient. They can carry lot of load on board. And when you have to fly subsonic speed, then it is widely used. Any passenger jet, Boeing or Airbus that you see today, they all employ bypass ratio turbofan. Jet, they have very low bypass ratio. Bypass ratio means certain amount of air is bypassed the engine. It is not going into the engine, but it is bypassed in a particular way so that you can get a more thrust or efficient thrust. So what was the requirement that was raised by American Air Force during that time? It is very high compressor pressure ratio, somewhere between 10 to 30 they needed. And they were ready to use a novel technology like stator and dual rotor. Dual rotor means you have two rotors rotating. So one is called low spool, one is called high spool or low power and high power. So that way you can improve the performance. Instead of compressing everything in one go, you are dividing the compression process in more than one stages so that your overall performance is improved. And they wanted to employ very high turbine inlet temperature. What is the implication of turbine inlet temperature? If you have very high turbine temperature, you can have more amount of thrust. Okay? When you learn in fundamentals of propulsion during your study, you will come to know that. And very high bypass ratio means engine is a little less noisy and exit temperature will be little less lower than the normal low bypass ratio engine, and it will improve the overall performance of the engine. That's why it is needed. If you talk about fighter jet, if you when you employ high bypass ratio, your exhaust gas will have low temperature relatively. So because of that, your heat signature can also get reduced. It's like that. Otherwise, a normal turbojet engine, if you calculate, you will get about 700 to 800 Kelvin as a outlet temperature, which is very high. So when jet propulsion is made up of turbojet, turbofan, turboprop, then what are the components and what type of design they take? So a fundamental is gas generator. Gas generator does nothing but to generate the exhaust gas, nothing else. So what you see here, compressor, it compresses the air. It goes into the combustion chamber, just like your compression stroke, then you have power stroke in IC engine. In the combustion chamber, you burn your fuel with air, and then you get high temperature, high pressure air, and that is expanded through turbine. Turbine is power generating unit. Compressor is power consuming unit. So once we expand it through turbine, it will generate some energy to run the compressor directly. In aircraft, they are directly connected, and it will keep on rotating. And whatever is remaining gas, it will be used for like heating water, or useful in boiler, or if you want to use it some other manner, whatever manner you want. So here we don't talk about the use of the exhaust gas directly. What we want is to run the compressor. You can connect this compressor with some pump and you run it, and your pump will keep on working. Like in rocket engine, you need uh, turbo pump systems to supply your fuel and oxidizer to the combustion chamber. If you remember diesel engine, you need pump. Petrol engine don't. Petrol engine usually are gravity feed. So that kind of pump, you need some energy to run that pump. So it can come through this kind of gas generator. But in gas generator, if you add inlet and if you add nozzle, both are opposite in design. In any case, one is divergent, other one is convergent. Depends on the which speed you are flying. So it becomes a turbojet engine. So gas generator added with inlet and nozzle, you can get turbojet engine. So the inlet helps you to get a pressure and temperature useful for the compression process, and it will improve your output. And the nozzle will expand the flow. Nozzle will generate the high velocity gases, convert the potential energy into kinetic energy, you can say, or pressure energy into kinetic energy to be precise, and you will get the thrust. Now this was the earlier era, 1935, 1940. So this exhaust gas can be of very high speed. It can go to like 500 meter per second, even more than that, even on ground. So if you read any aircraft maintenance manual, you will find that they don't allow you to stand up to certain distance behind the engines. And this is one of the reason we don't board from the backside of the plane. If you visit any airport, the plane's cockpit will always face the boarding gate, because if they switch on the engine, even for idling purpose, the hot gas can damage the boarding gate window glasses. So plane always face their cockpit towards the boarding gate. It's like that. Here, what you see is two spool engine or multi-spool engine, you can say, or that more than one rotor thing that US uh, government needed. So low pressure compressor will deliver some pressure air to high pressure compressor and it will rotate. Both of them can rotate at different speed and you can get your things done. The first was developed by Hans von Ohen in 1939 and Vittel was successful in 1941. So both of them are again credited for the first turbojet engine because they did not know each other at that time. It was not a copy, plagiarism in, as per current terms. Now you have some thrust, but you know we need more thrust. Then just like you have supercharger turbocharger in your four wheeler, we have afterburner. So after you have power extracted to run the compressors, you still have some air available, hot air. You again put some fuel into that, you will get more thrust. Afterburner nowadays is part of the fighter jet engines like MiG-29, Sukhoi 30, F-16 or the new one Rafale. Almost all the super that fighter planes when they take off they have to switch on the afterburner usually because it will generate a very high thrust and because of that thrust they don't need large distance to cover for takeoff like that. And during the flight, during the dogfight, if they want to get away from the enemy coming from behind, they can switch on the afterburner and they can have very high speed suddenly. It's like sudden jump. It is as simple as that. But it consumes a lot of fuel. Your fuel requirement increases by up to 50% when you switch on your afterburner. So they don't fly with afterburner every time continuously. When they need it, they switch on for the time being and then they switch it off. So this is the engine J79 by General Electric. It was used in Phantom and Hustler plane long back. So you just check the dimension. 5.3 meter is the long. That is about 15 to 16 feet. But the diameter is only 3 feet. Close to 3 feet. And the jet engine where there was no fuel and not the extra assembly, it is 1750 kg. The black region towards the towards the right hand side of the image that you see is afterburner. So afterburner length can be equivalent to your engine length without afterburner, and it adds the weight. Any material does not come without weight in aeroplane, so it adds the weight. That's why you have to be careful whether you want to go for afterburner system on board or not. Then came the era of after 64, 65, 1965, they came the era of high bypass ratio turbofan. Even till now, it is continuing. That is, you take some air, but you bypass part of the air. But you compress it before bypassing it, so that it will also also give you the thrust. So that is known as cold thrust because you don't burn that air with the fuel, and other part is known as hot thrust. Now the benefit of this is you can have the cooled engine. It's like radiator, you can say. So that air is passing over the engine, so you can have the surfaces cooled down. Second, that air does not contain exhaust gas, carbon dioxide and water. So you can use that air for cabin also, like AC purpose and breathing. We need it, passenger comfort. So that is also the way it is useful. Depending on design, they can either take from the compressor, they can take from the bypass. That depends on the design, their requirement. So nowadays, all the passenger jet, again I'm telling you, they use high bypass ratio engine. So the one that you see when you are standing in front of the plane, it can go up to 20 feet diameter, the larger one. And inside that you will have very small size. As you can see on the from the figure, you can imagine the diameter of the core region will be almost half than the diameter of the fan. And this fan operation is also important because it helps you to reduce the noise ultimately. This is the engine. Unfortunately, I could not put a bigger image. But this JT9D engine was Pratt& and Whitney division of UTC Systems. They developed that. Right now, it is used in 747, 767, A300, 310, and DC-10. DC-10 was more one of the popular planes in the world. Three-engine plane, if I'm right. So these engines, once they make one engine, it is useful for many aeroplane, and sometimes the development of the engine takes the same time for development of the aeroplane. So engine development is a totally different process, but it can take the same time, the time taken by the plane development. So 10 years for one prototype coming out from the design for aeroplane, 10 years it can take for the engine manufacturer to design the engine for that particular plane. But once developed, you can keep on modifying on that and you can improve the performance, of course. Then once you are done with low speed of turbofan, you want to go even lower than that. You don't need very high speed, like close to 400 or 500 kilometer per hour speed, if that's what you want, like in cargo plane. So it's like you increase your loading, your top speed will reduce, like truck and bike. Bike cannot carry 3 tons of weight, concrete, but truck can carry. And the truck is not supposed to be driven at 120 kilometer per hour speed in the Indian roads. But bike can easily ride that way. So you use propeller. Uh, these engines nowadays are visible for small aeroplane like Mumbai to Sirdi flight or maybe Surat to Mumbai flight. Or similarly, Kandla also has SpiceJet has some planes. Airbus, Air India also have similar plane which you can see your propeller 40-45 seater plane. You have to go there and board. You have to put your luggage manually in the luggage hold and all these things. So turboprop, they have gas generator only, but added of propeller system. Similar things can be useful for ship also, but ship propeller design for ship is totally different than propeller design for aircraft. The loads are different and the working environment is totally different. So these engines, turboprop, turbojet, turbofan, they are longer engines. But if you want to compact in size, if you want to reduce the size when you don't have the space like helicopter top, then you can use turbo shaft engine and you can generate the good amount of power and get away with that. So turbojet, turbofan, we rely on the thrust. That's why we don't want it to be compressed and consume, take out all the energy from the gas. But turboprop and turbo shaft, we don't rely on the exhaust gas too much. So we can reduce the size somehow and get the things done. And the easiest to manufacture, difficult to make, and ideally it should be designed very first point actually. First time it should be designed and it has not been designed till yet, it is ramjet engine. All the controversial thing. It doesn't need compressor. It doesn't need turbine. What it needs? A duct. Inlet is a duct. There is no component. Combustion chamber is a duct. There is only fuel sprayer, fuel injector, and nozzle is also duct without anything inside it. So it is the simplest design, but not developed successfully in commercial world yet. Okay, so it is known as ramjet engine. Once you are in supersonic region like Mach 2, Mach 3, you cannot have a compressor which can compress the air coming at that speed. Even if you try to compress, it will reduce your performance ultimately. So people have developed ramjet engine which compresses the air just because of ramming effect. Like the sand is ram for the construction of road, so that the space is reduced between the molecules. And this engine with turbojet engine has been used in SR-71 Blackbird. It is known as turbo ramjet engine and it is able to fly at Mach 3 plus speed at very high altitude. So components we talked about, inlet is there, compressor is there. These are the components. So what they do and what they look like. Just the intro for you people. Inlet. The purpose of the inlet is to reduce the air velocity and reduce it to the level where compressor can take it. Its operation and design affects the compression process. It has to reduce external drag and the mass flow into the inlet should be maintained. So in your bike or in your car you have air inlet through filter. If you chop their filter, ultimately your engine performance will go down. Here you don't have air filter system, but the performance affects your overall engine a lot. Inlet and compressor, they are going against the nature. We are slowing down high speed flow and it is difficult to control that. Based on your speed, you have two types of inlet. One is called subsonic, one is called supersonic. When you fly at low speed, lower than air's sound speed in air, you can call subsonic. When you are flying at speed higher than sound speed, you can call it supersonic. The design of both the inlet is totally different. Subsonic inlet, it looks like this. Passenger jets that we see, they are supposed to operate at design speed, and at design speed, it will have maximum efficiency of compression. And when you travel at lower or higher than that speed, your efficiency is reduced. Please remember, in aerospace engineering or in aircraft, there is not a component which is designed to run at other than design point. We expect that all the components are to be operated at design point only, maximum time. This is supersonic inlet, totally different. You can see the video of SR-71 engine. You will find that even MiG-21, if you see, there is a red con at the front of the MiG-21 tail, which is required to maintain the mass flow rate coming inside the engine. It is also part of inlet system. So what happens when you have supersonic inlet? You have to fly at subsonic speed first to reach supersonic speed. So when you are in subsonic region, the inlet will degrade your engine performance. And if you are in supersonic, it is okay. So if you have supersonic inlet design, don't waste your time to fly at subsonic speed. Compressor. They are useful to increase the pressure. The one that we use in a cycle shop or garage also. Compressor increases the air pressure. It provides the air for the combustion process and in a way so that your power extraction process is more efficient. So compressor has to provide the high pressure as not only that, it will provide in a way so that your combustion is efficient. Two types of compressor are used, centrifugal and axial, but in passenger jets we use mostly axial flow compressor nowadays. In certain small aeroplane we still can have centrifugal compressor as part of gas turbine engine. So yes, centrifugal compressor is nothing but the pump in your home, motor, water pump, or engine. What it was similar to submersible. Even if I am correct, I have not seen the submersible, but that kind of things are for centrifugal compressor. Even hair dryer will have that thing. Only three component: impeller, diffuser, and manifold. Impeller rotates, diffuser increases the pressure, manifold collects everything. That's all. And these are robust in nature. Operating range is very high, but it will create high frontal drag. So frontal area is more, so we don't use it in aeroplane. That's the major reason. But axial flow compressor, number of stages are more. That means you have more component to fail. One is called rotor, the left one. The middle one is called stator. Once you combine them together, your axial compressor is done. So manufacturing of axial compressor is costly affair because it works on aerodynamics of the compressor blades also. And but it doesn't have uh, frontal area, larger frontal area. And operation range is limited, but when you are operating in near your design point, your life is easy. Then combustion chamber or burner. You burn everything. After you complete your compression stroke, you are inside the power, you reach the power stroke area, you burn everything. Whatever air is coming, you put your fuel, burn it, but make sure that the gases exit at uniform temperature. Just imagine you have gas stove in your home, half the burner is burning gas CNG, PNG, and half the burner is not working. What will happen to your vessel? Okay. So uniform distribution of the temperature is important for the combustion chamber design purpose. Whenever you burn something, you have pressure loss. So when you design your burner, it is totally a different type of subject in propulsion, combustion chamber designing. Your pressure loss must be minimum. Combustion efficiency must be high, in the order of 95 plus or 99 plus even. Burner should not blow out. वो जो डायलॉग आता है ना, जिस तूफान में ये दिए बुझ जाते हैं उस तूफान में हम लोग ये करते हैं वो करते हैं, that tufan is this. Aircraft engine is flying also at 90 900 km per hour speed. Air which is delivered maybe at 20 meter per second or 10 meter per second speed. But even at 10 meter per second speed, the velocity is 36 km per hour. Now think about lighting a match when you are traveling on your Activa or Access at 30 to 40 km per hour speed and continuously. So that is most important part, that it should not switch off or it should not flame out at that speed. And combustion should happen within the burner. Otherwise it will go into the turbine, it will burn. That should not happen. The burning process should be over within the small region of combustion chamber. That's why the design is difficult. People are devoted to design only combustion chamber, even in propulsion area. So if you don't know how compressor works, if you don't know how turbine works, still you have the opportunity for your career in combustion chamber. And once you make, remember, aerospace engineering is one of the branch of engineering where development happens first and then it is given to the civil purpose. Just like for space technology, HD came and LCD came. All these things came for space technologies. Then it was given for civilian people. Here also turbofan engine, high bypass turbofan engine came for military purpose. Then it was given for civilian purpose. This is a burner where flow is coming straight from the left. You put some air, fuel, it will burn, and ultimately it will heat the turbine stator and turbine rotor. Turbine will rotate. Just a schematic for you. So not only the air should go to the turbine, it should also make that turbine rotate also. So it is already at high pressure. If you lose the pressure during the combustion process, your game is over. Then comes a turbine which faces all the heat. So continuously operating in hazardous condition, like 1200, 1300 Kelvin temperature continuously. You fly 10 hours it is facing 10,200 Kelvin temperature at every second, continuously, without even forget a second, even millisecond also. So its purpose is to take the kinetic energy from the gas and convert into power. That is run the compressor or accessories like refrigeration plant of passenger jets or any other equipment required some energy, they will connect it to the turbine through some system, you will get it. Now at that high speed means 1000 Kelvin temperature running at 10,000 5000 rpm. So design of turbine is dependent on rotational speed, how much gas is coming, what are you expecting inlet and outlet temperature and pressure, exhaust velocity that you want, and required power output that you needed. All these factors put together, they will affect your turbine design. But for the 10 stages of compressor, you may need only one or two stages of turbine. So turbine area is very small as compared to compressor area. So remember, in propulsion, when you go against the nature, you need small baby steps, like climbing up the stairs. Climbing up the stairs takes more time than sliding down. Sliding down is using gravity. Go with the nature, life is easy, things can be done within one stage, two stages. Go against the nature, life is difficult, you have to make 10 to 20 stages sometimes. So just like axial flow compressor, you have axial flow turbine. Same way, you have rotor, you have stator, put together, you will get a turbine stage. Again, its design is also from aerodynamics point of view. So propulsion is not a totally independent branch. It connects the aerodynamics also. There are two types of stages that you can design for the gas turbine, this jet engine turbine. One is called impulse, which is on the left. One is called reaction, which is on the right. Impulse means it just changes the direction of the flow, but reaction means it generates reaction force on the aerofoil blade, and you get your rotation. So based on the requirement, again you choose which one you want to go for. You can go mix of that also. It's totally up to the designer and requirement. Finally, once you are through everything, you have to go out of the engine, that is nozzle, exhaust the nozzle. It increases the velocity, it straightens the flow. Subsonic will have convergent, supersonic will have convergent divergent nozzle. Again, it is a simple duct, but just like your hair dryer or blower, you have one connector in front of the exit, and it will give you the velocity at desired area based on the direction, based on the size of the adapter that you can put. If you have afterburner, then it will come after turbine before nozzle, and then after you have exhaust nozzle. So convergent nozzle looks like this. The if you stand behind the engine when it is parked, the plane is parked, and if you go behind the engine, you will see like this. That is a convergent type of nozzle for passenger jet. But supersonic, it is difficult to understand because it can have variable area. It has to fly subsonic, fly supersonic, so it can have variable area region, and the design is quite complex. You need mechanism to operate that. So think about the mechanism which is being operated at 500, 600 degrees Celsius with the surrounding temperature continuously. So optimization and efficiency in operation is important for any aerospace component. But propulsion and aerodynamics, they have to go together. You can have the best of the engine, but you cannot have best of the plane, which can use that. Or other way around, you have the best aerofoil geometry, aircraft geometry, but you don't have the engine to operate that. It should not happen. There are various ways by which you can improve your thrust, just like switching on turbocharger for a while or supercharger in supercars. So one is called water injection, which is used in the compressor, where you spray some water, which will reduce your compressor work requirement, and ultimately it will give you more thrust. But for this you will have to carry water additionally. That means added weight for the aircraft. So your power to weight ratio is slightly reduced. Afterburner, as I said, you burn the fuel in the afterburner section. So there is permanent part of the engine. You cannot connect it whenever you think you need for the mission and you have to do that. No. Then water injection can increase your thrust something by 50 percentage. And afterburner produces thrust at the expense of the fuel. So depends on that. Now this is the cycle that works behind the generic gas turbine engine for jet propulsion. Compression, then you add some heat, then you expand, then you reject the heat. And efficiency, thermal efficiency, if you want to see based on the pressure ratio of the compressor, it is like this. Higher the pressure ratio, higher is the efficiency. But after certain value of pressure ratio like 30, it doesn't improve much. It becomes almost straight line after that. So increasing the compressor pressure ratio does not mean that you will have too much improvement in your overall performance. So you have to stop somewhere. I will skip this. Let me say that about ramjet engine. So when you say this is the engine I am designing, I want to design this What you do is actually you analyze the cycle. So cycle analysis is nothing but the you carry out the study of thermodynamic changes of the working fluid, which is air usually. So this figure is for ramjet engine, and under ideal conditions, the specific thrust, that is thrust per unit mass flow rate, is given by this particular equation, where A0 is free stream sound speed, M0 is free flight speed, T9 is the nozzle exit temperature, T0 is free stream static temperature. So what is the purpose of doing this cycle analysis? Is something like this. These are the plots that we have made using MATLAB or GNU Octave software. So this 1500, 1600, 1900, 22, 23, these are the maximum temperature inside the engine, that is after the combustion. So what we can analyze from this is, if you have higher the temperature, it will be higher thrust, like that. Similarly, higher the temperature, fuel air ratio is reduced. TSFC, thrust specific fuel consumption, higher the temperature, it slightly increases, but not much. And this is how the ramjet operates. It's the easiest engine, that's why I have taken. So you have inlet, then you compress the air. Just because of the speed, it will be compressed. Remember, no moving parts. You add the fuel, it will burn, and you expand it through the nozzle, ramjet engine. So this was a very basic idea about why jet propulsion is useful, why you should learn. You can improve any component. There are people who have done PhD only for inlet design. Even the leap of the engine, cowling, people are doing research. So you can take any small topic, flame holder, compressor blade, compressor rotor steer interaction. People are working on 1 mm of gap between rotor and the casing. So you can take any of this topic for your research, for your understanding, and you can make your career in propulsion. There are not many companies that make gas turbine engines in the world for aircraft. You will count with your own hands. Maybe you will not be able to name all the companies, but you can study if you are interested in jet propulsion. And jet propulsion requires fundamentals of thermodynamics also. So I included that. So now I will conclude this. You can make your career in jet propulsion. There are certain colleges in India for masters if you are already done with BTech, and it is one of the most um, beautiful branches of aerospace engineering. It's like that. Your creation will remain there for 20-25 years, like an engine. So that's all from my side. We can take questions with Ankit sir's permission. What he says.
Uh, Thank you, Jigar sir. We will go ahead and take some time for the question now. Just a reminder, please be sure type questions to my number 9978225359. I repeat again, 9978225359. Uh, it looks like we have some question.
Yes, sir.
What is the latest propulsion technology being used in spacecraft and how it varies from aircraft?
In rocket, propulsion, you can carry your oxidizer with you. So if it is a second stage or third stage of rocket, you can use liquid hydrogen, liquid oxygen also. And if it is for small amount of thrust that you need, like uh, what do you call course correction during the flight, then you can use another type of like hypergolic propellants are there. But the things that you learn, that electronic ion propulsion or magnetoplasma or magnetic hydrodynamics, all these things are in experimental phase. So they may develop a small engine put on the rocket just for testing purpose. They may not give you the perfect thrust that you need from the beginning. They can test there. It's like that.
Second message is, sorry, second question is, What is cryogenic engine?
Cryogenic means very low temperature. That is a engine. That is a science. So once you pull down the fuel and oxidizer even below their liquefaction temperature, let us say water is liquid above 0 degree Celsius, right? But if you can freeze it in a way, store it in a way so that it is very very low temperature, continuously maintained, then we call it cryogenic. It is nothing but a very low temperature science for gases. It is very very low temperature.
Uh, our question is name of engine manufacturing companies.
Oh, one is known to us General Electric. General Electric, then Rolls Royce. They don't make only cars; they make engines also. Pratt and Whitney. Then Snecma is a French company. Then Alison, there was a company called Alison also, but because of the requirement and competition from other companies, they may merge together. They may develop engine together. Like Snecma is combination of uh, Rolls Royce and General Electric, if I'm correct, and they develop new company to survive in the industry. We in India we have research center for General Electric and this one, Pratt and Whitney.
Okay, thank you very much, sir, for sparing
Thank you,
your
sir.
valuable time, and thank you, everyone. We appreciate you being here. I would like to present an appreciation certificate on behalf of Paral University to Jigar, sir.
Thank you, sir.
Uh,
Let me switch off the
just a minute, sir.
presentation. Thank you, sir.
Okay, thank you, sir.
So once again, thank you, Parul University, for giving me the opportunity. Thank you, Ankit sir. I hope whatever we expected, I have fulfilled, and will remain in touch for future collaboration on certain things.
Thank you very much, sir, for sparing your valuable time. And we will having our next webinar schedule on next week. Please do join us for the same, and we will update you for the timing soon. Thank you again for joining us today, and we will see you next time. Have a good day, all of you.
Bye, sir.
Bye, sir.
I'm signing off now.